Okay, so let's jump right in. We're talking about the angle grinder. Now, this is probably one of the most common tools you'll find in any workshop, right? But it's also an absolute monster of kinetic energy. It looks simple, but what's packed inside this tool is a level of force that honestly demands a huge amount of respect. And just to give you an idea of what we're dealing with, that disc is spinning at over 12,000 revolutions per minute. I mean, that's way faster than the red line on most high-performance sports cars. Now here's the scary part. If that disc fails, if it shatters, the fragments can launch at speeds over 300 kilometers per hour. That is literally the takeoff speed of a commercial airliner. So yeah, you're holding a seriously high-energy system right there in your hands. So that brings up a really important question, doesn't it? With all that incredible power, what's standing between a productive day and a total disaster? What is this invisible system that stops this tool from basically becoming a grenade? Well, the answer actually starts right on the wheel itself. You see all that text on the label? That isn't just for show. It's actually a dense coded language of safety. And learning how to read it, well, that's your first line of defense. And here's the thing you've got to remember. These markings are not suggestions. Thanks to standards like EN 1214, they're part of a universal language. It's how the manufacturer talks to you, the person who's about to spin this thing at unbelievable speeds. Okay, so let's break this down. Every little mark here is a layer of safety. That EN 12431 stamp, that tells you it's passed a whole bunch of tough safety tests. The max RPM, that's the absolute do not exceed speed limit. The expiry date, that's there because these wheels, believe it or not, go bad over time. And those little symbols, they're critical warnings, like don't put sideways pressure on this cutting disc. Every single mark is a safety check. So we know the wheel speaks its own language. But now let's zoom out a bit, because this one wheel fits into a much bigger picture, a whole global safety net of rules and regulations, all designed to stop accidents before they can even happen. Over in the EU, the whole philosophy is pretty straightforward. Safety begins at the source. The Machinery Directive basically says the legal responsibility is on the manufacturer to design a safe tool from the get-go. And standards like EN 12413, that's the rulebook they have to follow to prove they did it right. Now, in the US, the approach led by OSHA and the super detailed ANSI B7.1 standard is all about physical protection. The regulations are, you could say, obsessed, in a good way, with the guard itself, making sure it can actually contain an explosion. And they're just as obsessed with speed control, making sure the tool can't possibly spin the wheel too fast. And then you've got the UK, where under their PUWER regulations, they do something really interesting. They put this powerful focus on the person holding the tool. See, it's not enough to just have a safe grinder. The law actually demands that the operator is proven to be competent. Training isn't just a good suggestion, it's a legal requirement. All right, we've talked about design, we've talked about rules, but there's a hidden enemy that affects every single one of these cutting and grinding wheels, even one that's brand new, just sitting on a shelf. It's a slow, invisible process of aging. The culprit is a chemical process called hydrolysis. The easiest way to think about it is this. The resin that holds all the abrasive bits together is kind of like a super strong glue. The problem is, this glue just loves to suck up moisture right out of the air. And over time, that water starts a chemical attack on the bond, weakening the whole wheel from the inside out. It's a really simple but kind of devastating process. So first, the resin soaks up that humidity. Then, those water molecules get right in between the glue and the grit, and they just break that bond. The result? You've got a wheel that looks perfectly fine on the outside, but it has lost a massive amount of its internal strength. And just look at the real-world impact here. Research shows that a wheel stored in a nice, controlled, dry place loses almost no strength at all. But take that exact same wheel and leave it in a warm, damp garage for just 1 year, and its bursting speed could drop by up to 60%. That is a huge, invisible drop in its safety margin. And this right here is exactly why that expiry date we saw earlier is so critical. For these common resinoid wheels, the safe shelf life is 3 years, period. After that, the risk from this hidden water damage is just too high to trust it. Okay, so we get the wheel, we get the rules, and we get the hidden dangers. Now let's bring it all back to you. How do you actually use all this information? Well, it really comes down to having a simple pre-flight checklist that you run through every single time. So before that wheel even gets near the grinder, you do 3 things. First, you give it a good visual inspection. You're looking for any damage at all, cracks, chips, anything. Second, for the harder ceramic wheels, you do the classic ring test. Tap it gently. A nice, clear ring means it's good to go. A dull thud means it's cracked and you need to destroy it. And third, the absolute most important check. Make sure the RPM rating on the wheel is higher than the max RPM of your grinder. Never, ever break that rule. Mounting the wheel is a science, not a strongman competition. You have to use the right flanges and they have to be clean. You absolutely must use those little paper blotters. They're like gaskets that spread out the pressure evenly. And you only tighten the nut with the wrench that came with the tool. No extra muscle, no hammers. And here's why. The experts warn that cranking down on that nut with all your might, or worse, hitting it with a hammer, doesn't make it safer. It can actually create tiny, invisible micro cracks in the wheel. You'll never see them, but they can cause that wheel to just explode minutes later when it's spinning at full speed. Now, once you're up and running, the rules are just as critical. Always, always use 2 hands for control. When you put a new wheel on, let it run free for a full minute. Point it in a safe direction just to make sure it's sound. When cutting, never twist the blade in the cut. And when grinding, you want to keep that angle between 15 and 30 degrees. But you know what? Even if you do everything perfectly, with a brand new wheel and flawless technique, things can still go wrong. And when they do, with pieces of that wheel flying at the speed of a jet, what is the absolute last thing standing between you and a life-changing injury? It's your PPE, your personal protective equipment. And for this tool, it is completely non-negotiable. I'm talking high-impact safety glasses plus a full face shield, hearing protection for that intense noise, a proper dust mask for whatever it is you're cutting, gloves to protect from heat and cuts, and flame-resistant, tight-fitting clothing so nothing can get snagged. So, when you boil it all down, here's the key takeaway. Angle grinder safety isn't about just one thing. It's a whole system. It starts with the chemists who design the resin. It flows through the international standards. It goes to the engineers who design the guards. And it ends with you, your knowledge, and your discipline in the workshop. And that really leaves us with one final thought. The next time you go to pick up that angle grinder, or really any power tool, are you just going to see a tool? Or are you going to see this whole invisible universe of science and rules and best practices that's been built around it, all designed for one single purpose: to keep you safe?